Y'all, this thing legit cut me off, so I'm starting where I left off. Is I was trying to tell you at the bottom here, we have two examples, and say we have 50 going up and 50 going downward. They are still balanced with one another. 30, 30, still balanced with each other. In other words, what I'm trying to point out is that not all the forces have to equal each other themselves, but if they're in the same plane, like the 50 and the 50, they cancel each other out. So this is a situation where they are balanced. They are in equilibrium. Unbalanced forces, on the other hand, is exactly what it sounds like. The forces on one side don't equal the forces on the other side. So then that makes a net force not equal to zero. And then the object will accelerate in the direction of the unbalanced force. As an example, down at the bottom here, we have an applied force that's greater than the frictional force. So this object will accelerate to the right. The object will accelerate in the direction of the unbalanced force. So that begs the question, what do unbalanced forces cause? They cause acceleration in the direction of the unbalanced force. Okay, everybody's favorite answer to this is, what is inertia? Everybody's favorite answer is Bill Nye, what he says, property of matter, right? Okay, cool. It is a property of matter, but what else you got? Okay, it's the tendency of an object to stay doing what it was doing, to maintain its state of motion. So if it were sitting still, like when you're in an elevator and you go and you stand in the elevator and then you press to go up, your body has the tendency to stay still. That's why it feels like you're being pulled into the floor, but that's not really what's occurring. Or if you're going constant speed, like in a car, and then you automatically apply those brakes, then your body goes forward because it continues to go at a constant speed in a straight line path. Inertia is synonymous with mass, right? And mass is in kilograms. So if you ever think of inertia, think mass. Mass and inertia are the same thing. However, weight is a force. So that would pretty much mean like, oh, weight, mass, not the same thing. Your tip off is going to be if you see newtons. If you see those newtons, that's going to be the weight of the object. So are mass and weight the same thing? No. How do you know? Weight is a force because forces are in newtons. Anytime you see newtons, that's going to be a force and not a mass. As an example, sometimes you're going to see F with the subscript W. Sometimes you're going to see F with the subscript G. And then occasionally you will see a capital W. Just wanted to throw that out there for you. Remember the age-old Newton's second law of F equals ma. We're going to utilize that to our advantage. If we have the mass of 60 kilograms and an acceleration of negative 9.8 meters per second squared, y'all already know that's the gravitational acceleration on Earth. If we were to utilize that, we would do 60 times our negative 9.8 to then give us negative 588. Why in the heck is that a negative 588? Because it's pulling downward. And remember, forces are vectors, so they have to have that negative in there if it's pulling downward. Another thing I want to point out is sometimes instead of AG for the acceleration due to gravity, you might just see a G. All right, y'all, that is it for forces for today.